we said that these four things were true whenever we have a parallelogram. So the first thing that the problems did yesterday was they said, if this is a parallelogram, then what can we prove about these angles or these sides or these diagonals, whatever it might be. Okay? Well, today we're going to kind of flip it. Instead of them telling me that it's a parallelogram, we're going to prove that it's a parallelogram. Okay? And so we're going to use some of those properties that we did yesterday to prove that the figure that we have is a parallelogram. Okay? And so how do we do that? Well, we're going to talk about some examples and some things that we're going to have to do to get there. First up, a formula that we're going to need today. That we haven't used for a while is the midpoint formula. So I'm going to put that up here at the top of our notes. Midpoint is going to be able to find the point that's right in the middle of two segments. And I'm going to show you in just a second how we're going to use that and how we can use that to help us prove that we have a parallelogram. But first of all, I'm going to show you a couple of different ways that we can do this problem. But it kind of depends on, like when we get to big ideas today, what direction they want us to kind of go in, how we want it to prove it. There's kind of an easier way to prove it, but then there's some other things that they're wanting us to do as well. So we have 4 points here, L, M, N, and O, and we're going to plot those 4 points on our coordinate plane. So we have 0, 0, we have 6, 0, we have 7, 4, and we have 1, 4. Okay, now this one is talking about the intersection of the diagonals, and we're going to talk about that here in just a second. But if I really wanted to prove that these make a parallelogram, these sides make a parallelogram, then I would need to show that these two are parallel. Well, are LM and ON parallel? What do you guys think? What does it mean to be parallel? So you're thinking perpendicular. Yep. Perpendicular would be opposite reciprocals. Yeah, they're the same, right? And it's been a while since we've talked about this, but when I have a line that's horizontal like this, what's the slope of a horizontal line? 0. Yep. So this one has a slope of 0. This one's also a horizontal line. Okay, it just stays flat. So it's also a slope of 0. And so the first thing I'm going to say here is that LM is parallel to ON because they both have a slope of 0. Remember, little m represents slope, so when I write little m here, it's just an easy way of saying slope. They both have a slope of 0. That's how we know that they're parallel. Okay, when I look at OL and MN, we're going to do rise over run. Okay, good old slope. If I go from O to L, we're going to count. We're going to do rise first. 1, 2, 3, 4 over 1. Over here to go in to M, we're going to go 1, 2, 3, 4 over 1. Okay, so both of these, I'm going to say that OL equals MN because they both have a slope of 4 over 1, right? And so I'm going to say that OL is parallel to MN because they both have the same slope. So that's how we could prove that we have a parallelogram. We're saying that we have a parallelogram here because we have two pairs of opposite sides that are parallel. But what we're going to do here is we're going to use the fact that it's a parallelogram, and we're going to prove some things about the diagonals. So the diagonals of these two would be OM, and it would be LN. And you can't just go by looks here, right? We can't just look at this and say, oh, I know what the intersection of those two is going to be. Because it's not at a nice ordered pair. It's not like at a point right here or right here. It's kind of in between two other points. So what we're looking for is we're looking for the intersection of those two diagonals, okay? And so here's what we're going to start with. OM. If I look at OM and I want to find the midpoint of OM, O is at 0, 0. M is at 7, 4. So we're going to do 0 plus 7 over 2. I'm using the formula that I just put up here, right? Because I'm going back to this formula. So I'm doing 0 plus 7, because those are my two x values, divided by 2. And I'm going to do the same thing to my y values. 0 plus 4 divided by 2. And if we simplify this, 0 plus 4 is 4. 4 divided by 2 is 2. Or if you would rather write it as a decimal, you could do 3.52. And what that tells me is we're going over 3.5, 1, 2, 3.5, and up 2. And that's where those two intersect each other. We could do the same thing then for the other diagonal. We could do LN. LN. I'm going to pick the 2 points that make up LN. L is at 1, 4. N is at 6, 0. And so once again, we're going to do our midpoint formula. 1 plus 6 divided by 2. 4 plus 0 divided by 2. 1 plus 6 is 7 over 2. 4 plus 0 is 4. 4 divided by 2 is 2. And so these two have the same midpoint. Yesterday when we talked about the diagonals of a parallelogram, we said that the diagonals bisect each other, okay? And when the diagonals bisect each other, then they're going to be intersecting at the same point. They're going to split each other in half, okay? So those two should have the same intersection point where they intersect at. Okay, try doing this one down here. I'll do it as you guys do it, but plot the points and then find the midpoint. You don't necessarily have to do the slopes and all of that unless you want to, but find the midpoint of the two diagonals. But plot the points first that they give us. Anybody get the intersection, midpoint? 2, 3, okay. So if you draw that picture up here, one of the reasons why it's good to draw the picture too is you can see the two diagonals. T and B go together, so that's why I put these two together. S and U go together. Now, here's what I'll tell you. S and U, it's a nice horizontal line, right? And if I count 1, 2, 3, 4, 5, 6, 7, then the midpoint is going to be right in between those two. And so you could do that really quickly. It's actually 8. So 1, 2, 3, 4, 2, 3 would be this point right here. Okay, so the intersection of these two is this point right here. Okay, and you could draw the two diagonals in there, but that would be the point that's right in the middle. That point should be directly in the middle of that. It's not always going to be a nice whole number, so that's why you can't just look at the picture and say, oh, I can tell where these are landing, right? The one that we did up above was a decimal, and so that would be kind of hard to tell just by looking. But that's kind of what we're doing there. When it talks about the intersection of the diagonals, that's kind of what they want you to work through. You'll have some problems on big ideas like that where you'll have to work through the midpoint and show that they have a point right in the middle of the midpoint. Okay, this one at the top of the next page. They give us 3 vertices of a parallelogram. We have to find where y would be, okay? We got to figure out where that point y would end up at. So the first thing, kind of like we did on the last one, except here they only give me 3. We're going to plot w, x, and y, or w, x, and z. We don't know y. So we're going to go -1, -3. That would be w. We're going to go -3, 2, which would be x. And then we're going to go 4, -4. So we can kind of start to imagine a little bit of where that point's going to be. We know that point's going to be somewhere around up here, right? Well, here's kind of the process that we got to go through. So I'm going to start by connecting these points together. And I got to figure out what that 4th point is going to be. Well, I know that w, x, and zy are going to be parallel to each other, right? So if I figured out what do I have to do to get from w to x? So I want the slope of wx. And there's a couple of different ways that you could do it, okay? You could start at x and go to w. You could go to w and go up to x. Typically, we would start to the left and go down to w. And in that case, it would go down 1, 2, 3, 4, 5 over 2, right? So if I go down 5, that would be a -5. And then I go right 2, which is a +2. If you started at w, I would go up 5 and left 2. And so in that case, it would be 5 over -2. It doesn't matter where your negative's at. I can have a negative on top. I can have a negative on bottom. Those two are the same thing, right? They're both -5/2. They just have a negative in a different place. So it doesn't matter which way you go. Either one of those are fine. Now, it might be better to start at w to get to x because we're trying to figure out where y is going to be. So if I started at z, I'm going to use the same slope, right? I'm going to use 5 over -2. And remember that this is rise over run. So that tells me from z, we're going to go up 5. 1, 2, 3, 4, 5, left 2. And that's where we would put y. So it wants to know where is y going to be. What would be the ordered pair for y? 2, 1. Over 2 and up 1. Here's kind of a way that you could check your answer as well. What do we know about x, y, and wz? What would be true about those two? The top and the bottom side. They also got to be parallel, right? So to get from x to y, I'm going to go down 1 and then over 1, 2, 3, 4, 5. And then wz, I'm going to go down 1, 1, 2, 3, 4, 5. Both of those have the same slope, negative 1 over 5. Okay, so that just kind of verifies to me that this does make a parallelogram. We've placed y in the right spot. Everything works out. Okay, everything should work together if you're going to make this a parallelogram. Both pairs of sides. You can kind of look at it. If it doesn't look parallel, then what did you do wrong? Where did you put it? Is it in the wrong spot? Okay, try doing this one. Same thing as we did on that first page. Try placing the 3 points and figuring out where the 4th point would be. See if you can do this one. I'll do it as you guys do it. Okay, what do we get for the 4th point here? Anybody get it? 0, 1. Okay. D should be at 0, 1. If you're not sure if it looks right or feels right, then just make sure these two are parallel. D to C goes down 2 over 3. A to B goes down 2 over 3. If I wanted to go D to A, I would go up 3 over 2. Here I would go up 3 over 2. Both sides are the same slope, right? Both sides are in the same relationship, same rise over run, opposite of one another. That's what makes it a parallelogram. Both pairs of opposite sides must be parallel to make this a parallelogram. All right, on this last one, it's some more kind of algebra again. And the one that we had yesterday, we had some like this on Big Ideas, and a few people were struggling kind of with the algebra thing of it. What you got to make sure of is if you're ever going to solve an equation, I can't really solve an equation that has an x and a y in it, right? And there was a problem yesterday that had like a, b, c, and d. Maybe not all 4, but it had like 3 variables for sure. And you can't set like a equal to c. And the example that I'm thinking of yesterday, we had something where like this was c and this was d. So I had some people saying that c is equal to d. True statement, right? C is equal to d. But if I don't know c and I don't know d, I can't really set them equal to each other, right? If I know that d is 100 degrees, then I know c is 100. But if I don't know either one, I can't just make up a number. So I got to know one in order to find the other. And same kind of idea is going to be in place here. Draw yourself a parallelogram. And you don't necessarily have to make a coordinate plane here. And I'm going to label this parallelogram A, B, C, D. it's asking us to find the perimeter. Okay, now before we even dive into this, when we are finding the perimeter of a figure, what are we really finding? The outside, the distance around. Okay, so what I need to know is I need to know the length of all four sides. Okay, they don't give me any lengths. They give me four expressions that I'm going to have to kind of use somehow to get where we need to be. Okay, so in this case here, AD is 3x plus 3. BC is 4x minus 1. CD is 5y minus 6. AB is 3y plus 4. Okay, it's doable without drawing a picture, but I think drawing a picture, it's a whole lot better visually to kind of see what's going together. Now, yesterday when we talked about parallelograms, not only did we say that opposite sides were parallel, but opposite sides are also what? Equal. They're congruent, right? They have the same length. So if I told you this side up here is 20, then I know the bottom side is 20. In this case, we don't know the actual length, but we know expressions that represent each one of those. So we know that AB is equal to CD. Because they tell me it's a parallelogram, we know opposite sides are congruent. We also know that AD is going to equal BC. Those two sides are equal as well. So I can take what I'm given and I can set them equal to each other. Here's AB, here's CD. So we're going to do 3y plus 4 equals 5y minus 6. Is that equation something I can solve? Do we have more than one variable in it? More than one different variables, I should say. No, it's just y, right? So can we solve that equation for y pretty easily? Yeah, okay. Over here, AD is 3x plus 3. BC is 4x minus 1. Same thing. This equation only has x's in it. This one only has y's in it. So we can solve those pretty easily, hopefully, using our algebra skills. Subtract 3y from both sides. I kind of like to combine two steps into one. If I'm going to move my y's to the right, I'm going to move my numbers to the left. And I get y equals 5. Over here, we're going to get our x's together. And we get x equals 4. Okay, and we've seen this and talked about it a lot. Sometimes it'll say solve for x and y, and we could be done at this point. But this one's asking us to take it a little bit further, okay? And it's not even asking us what the length of the sides are. It's asking us what the perimeter of the entire figure is going to be. So that's another reason why the picture, I think, is helpful here, is I'm going to take 5 and I'm going to plug it in here for y. 3 times 5 is 15. 15 plus 4 is 19. If I plug it in here, 5 times 5 is 25. 25 minus 6 is 19. These two sides better be equal to each other, right? If they're not, we've done something wrong. They're both 19, so that's good news. I'm going to plug 4 in for x. 4 times 4 is 16. 16 minus 1 is 15. On the other side, 3 times 4 is 12. 12 plus 3 is also 15. And then to find the perimeter, we would do 2 times 19 plus 2 times 15. You could just add all 4 together, but because there's 2 of each side, I'm just going to multiply it by 2. A little bit easier math, I think. So this would be 38 plus 30, and that gives me 68, which would be the perimeter of that parallelogram. Okay.